Today we're going to practice graphing a line using the slope-intercept form. So let's get started. So for this problem, we're asked to sketch the graph of the following line. We have the equation, this linear equation, y equal to 6/5 x minus 1. And we're going to graph this using the slope-intercept form. The slope-intercept form is y equal to mx plus b. And it's called the slope-intercept form because when the equation of a line is written in this form, we can look at the equation and see both the slope of the line, that is the coefficient for x, plus the y-intercept. So for slope-intercept, the intercept is where it crosses that y-axis. So we'll start with that y-intercept. For our example, b is equal to -1. If we rewrite this equation a little differently, so we have y equal to 6/5 x plus, and then we're adding a -1. The addition of a negative is subtraction. So b is equal to -1. This means we have the ordered pair 0, -1. And so we have the ordered pair 0, -1. So the x value is 0. And the y value is -1. So we found one point that's on our line. We found the y-intercept. Now we'll use the slope to find more points that are on this line. So for an equation written in slope-intercept form, that slope is going to be the coefficient of x. So in this case, it's 6/5. So when we're looking at slope, reminder, the slope is the rise over the run. So this is going to be the change in the y value, the rise, over the change in the x values, our run. So with a numerator of 6, that means we're going to rise 6 units. And then the denominator of 5, we're going to go to the right 5 units. So starting at a known point on the line, so this is our y-intercept, we're going to rise 6. 1, 2, 3, 4, 5, 6, and then run to the right 5. 1, 2, 3, 4, 5. And this is a point on that line. Now the fraction 6/5, we can also write this as -6 over -5. These are two equivalent fractions. +6 over +5 is the same as -6 over -5. So with the slope, we can also say that we're going to go down 6 and to the left 5. So from a point on that line, again, I'll start with this y-intercept. We're going to go down 6, 1, 2, 3, 4, 5, 6, and to the left 5. 1, 2, 3, 4, 5. And we have another point that's on this line. We now know 3 points that are on this line. And when I graph a line, I typically like to have 3 points at least. Because if I made a mistake plotting them, it'll become evident when I draw that line. So in this case, I connect those 3 dots, and those 3 dots all fall on the same line. If I had misplotted one point, it would not fall on the line. So here we have sketched the graph of this line from the equation using the slope-intercept form. And what we have drawn, when we sketch this line, every point that's on this line, all these ordered pairs, these xy ordered pairs that are on this line, are a solution to this equation. When we plug those values in, we get a true statement. So what does this mean? So let's take a look at a point on this line. Let's look at this point right here. And although you can't tell just by looking at this graph, this point is the ordered pair 4 for an x-coordinate, and the y-coordinate is 3 4/5. So we have a fraction for our y-coordinate. Let's see what happens when we plug this ordered pair, or any ordered pair that's on this line, back into the equation. So we're going to substitute in those x and y values. Our y value is 3 4/5 equal to 6/5 times x. Our x value is 4 minus 1. we're not going to do anything with this left side. I'm just going to continue to bring down this left side. This is equal to 6/5 times 4. That's 24/5. We multiply those numerators. Minus 1. Well, let's rewrite 1 to have a denominator of 5. So that's going to be 5 over 5. Now we'll do this arithmetic. 24/5 minus 5/5. So that's 24 minus 5. That's 19/5. Now we just need to rewrite this right side. 5 goes into 19 3 times with 4 left over. So we end up with 3 4/5 on the right side as well. We have a true statement. 3 4/5 is equal to 3 4/5. Every ordered pair that's on this line will result in a true statement. Every ordered pair that's not on this line will not result in a true statement when we plug it back into this equation. So the origin, the ordered pair 0, 0, is not on the line. Let's see what happens when we plug this point or any point that's not on the line into the equation. So the y value is 0, equal to 6/5 times 0, that's our x value, minus 1. So we have 0 equal to 0 minus 1, and this is 0 equal to negative 1. Well, 0 is not equal to negative 1. This is not a true statement. And that's exactly what we expect for any point not on the line itself. Therefore, this graph, the graph of this line, it represents all of the solutions to this equation. So if we have a collection of solutions, we can say we have a set of solutions. So another way of saying sketch the graph of the line is to say graph the solution set for the equation. And that's exactly what we did here when we graphed the line. So, a great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and graph the solution set for the following equation. So we're given an equation, and in this case our equation is in the slope-intercept form. So looking at the equation, we can find that y-intercept. It has a y-intercept of 3, so the ordered pair 0, 3 is included on the graph of this line. We can also find the slope. The slope of the line is negative 2/5. We can rewrite the fraction negative 2/5 as negative 2 over 5, which means we're going to go down 2 and to the right 5. Or we can rewrite the fraction negative 2/5 as 2 over negative 5, meaning we're going to go up 2 and to the left 5. These three fractions mean the same thing. From these 5 points, we draw our line. And then let's clean this up a bit. And this line is the graph of the solution set for the equation y equal to negative 2/5 x plus 3. Drop any questions you have in the comments. Continue practicing graphing equations in slope-intercept form, and I'll see you in the next video.